Beh, intanto buongiorno a tutti, grazie per la presenza. Sono Federico Giotto e oggi parlerò.
Good afternoon and thank you for being here. Today I'm going to discuss inactive yeasts, their potential and applications, perhaps one of the most relevant topics for the people in the audience. I'm part of the Giottoconsulting Training and Research Center that deals with enology and viticulture. To begin with, I'd like to mention that the work that we carried out on inactive yeasts is grounded in a very important reason, which I think is shared by many winemakers here, because the intent is to create wines that can highlight the identity of their area and soils while preserving their quality and soundness characteristics. While reducing, for instance, to a minimum the use of SO2 and other exogenous compounds. The role of yeasts is absolutely well known when it comes to fermentations. We know very well whether a given yeast can form volatile compounds, alcohol, or sulfhydric compounds, and so forth. Well, when it comes to other effects, especially what the yeast can do once the fermentation activity has come to an end and during the lysis process, is still something that is being investigated as we speak. For sure, we know that yeasts have a big impact onto the sensory characteristics, but also, as we have seen, there can be prominent reduction effects that affect the shelf life of the product. We also know that it has an impact onto protein stability, color stability, and tartaric stability. Not every wine can spend time on the noble lees, on the fine lees. Sometimes that is connected with problems associated with the reduction caused by the lees, and that forces the winemaker to eliminate them. And then sometimes the lysis timing is problematic because it may not coincide with the period of the best of time for the wine's sake. So the question we asked ourselves, can inactivated yeasts be comparable to fine lees? How can they be used and what are the criticalities if so? First of all, we understood that a yeast strain can interact differently with different effects on the composition, but other than the yeast strain, as explained in depth by Camuzzo, the lysis and inactivation and dehydration processes, when as applied to yeasts, play a key role. So we developed studies with Enologica Vason to see if it was possible to improve the lysis and inactivation of yeasts. Hence this brand new process, which is very innovative for the production of inactivated yeasts. This inactivation process takes place at low temperatures without the use of exogenous enzymes and without any oxygen whatsoever. The inactivation process never exceeds 35 degrees. We do freeze drying and no spray drying. Let's look at the substances and review a few important applications for inactive yeasts. We have seen that many have a well-established anti-oxidizing power. With the same type of yeasts, it is possible through inactivation to have 3 times as many thiols as you'd have with thermal activation. In terms of oxidization protection, we tried to understand from a technical perspective how we could have been most effective. We therefore started to work on musts to understand what would work best. We started with a color analysis to determine the colors, not through optic density for 25, 26, 20, but that looks at all the color scale of wine. Monitoring A and B specifically, that is green vis-a-vis red, and then blue vis-a-vis yellow. And then as last, light intensity. Analyzing the effect of the addition of inactive yeasts to must, something interesting was immediately evident. The must didn't have a tendency to brown, so that proved an almost instant effectiveness of the yeast onto the wine. Here we have Glera and Garganega musts. In the yeast activated with the X-Pro methodology, the amount of yellow is lower, and the green and red seem to prevail. So the analysis here were taken after just a few minutes after the addition of inactivated yeasts. We then wanted to measure how long that would stay over time. So we kept them at a stable temperature, and we saw that the inactivated yeast has a very interesting role in determining the color of the must. Why am I saying that that is interesting from a technical perspective? First of all, because since the antioxidant is not just SO2, which does because the interest is not just protecting from oxygen, but also the extraction of phenolic compounds. It can be interesting for skin contact macerations or débourbage, which is cold must under a batonnage before fermentation, or also mechanical separation where oxidizations begin immediately. In terms of aging and storage and shelf life, certain articles have been developed in order to analyze the ability to increase the shelf life and maintain and preserve the wine from oxidization. So we have already mentioned certain activities, and in particular, I think we should focus onto the ability on the part of an inactivated yeast to preserve a wine throughout the aging process. Just imagine the relevance of using this on sparkling wines where SO2 needs to be kept to a minimum. We worked on a 5-year frame around this TDO, which is the oxidization coefficient, which was studied using the CLab methodology on wines that were then added H2O2 at a temperature of 60 degrees. What we see here are the various curves that demonstrate the wine's response on this diagram. We started, therefore, understanding where oxidized wines would go. Analyzing hundreds of oxidized wines or over-oxidized, there was a specific area that they would position in within the TDO diagram. If you analyze a moderately young wine, the pattern would be in the shape of a curve like this, and curves differ depending on the type of wine, but after several days they all end up in the same area. An interesting application, these are commercial wines that we consult for, is this wine, which is SO2 free, for which we carried out tests to measure what would happen in the case of an addition of 30 grams per hectoliter of 2 thermal inactivated and 1 X-Pro inactivated. preparation. The effect onto the yellow color is very evident, as well as it is on the green scale. If you look at how that maps out in terms of oxidization curves, you see that the triangle plot is less easily oxidizable. The red and the yellow curves also show that these yeasts have a strong antioxidization role. After 30 days, there are wines for which you observe a reddish color that has developed, while the sample to which the inactivated, ex-pro inactivated yeast was certainly more interesting in terms of color and oxidization. Now, going back to what Camuzzo said before, one of the criticalities coming from the addition of inactivated yeast certainly is the olfactory profile. If you look at sample number 2, it is true that it looks more yellow, but it also contains more of a green color. But on the nose, the perception is more of a yeast note. This is not correct. It's like a cookie or broth or stock odor, a sensation of meat stock, probably an indication that there has been some oxidization, while you see an activity in terms of oxidization on floral and fruity. On the palate, or to the palate, you see the pattern that is meaningful in terms of bitterness and phenolic compounds and vegetal notes. So the wine, in this case, when you carry out tests towards the end of the wine processing cycle, and if you add these yeasts towards the end, it's important to carefully measure the amounts. We thought of the application. So we said to ourselves, when you clarify with bentonite, when you fine with bentonite, wine becomes more susceptible to oxidizations. If, for instance, you have a certain amount of glutathione and then you add 20 grams of bentonite, you will reduce dramatically the glutathione amount. So we thought of stabilizing the wine beforehand and then add inactivated yeast. So this is important because all the inactivated yeasts produced at low temperatures in this case seem not to interfere onto protein stability. Quite the contrary, they tend to have a protective role from such instabilities. So the idea is to stabilize the wine, and once it's been stabilized, before filtering, 10 grams can be added, as we did. 10 grams of inactivated yeast, and you can see two fractions. The first is the 19th of February, where we analyze the TDO 5 days after adding the yeast and bottling. And in the chart, you see lower propensity of the wine to redden, while on the bottom chart, you also see that the yellowing was reduced 5 days later. We also were interested in analyzing what would happen 2 months down the line. If you look at the chart bottom right, the yellow color remained unchanged from 5 days after bottling, while in the case of the red color, the propensity to develop a reddening was lower. I think this is a very interesting and important aspect because it implies that you can readjust the free SO2 doses applied with wines, and also thinking that wines are no longer just drunk in the nearest bar, but also often cross the oceans and need to remain stable throughout. Now, if you look at the top right chart, the propensity to develop a red color was even lower than 5 days after after the bottling period. Now, pinking. Pinking is becoming relevant around the world, but we see that in Italy as well, Lugana, and others. It is one of the most deeply felt problems. The one thing that can stop it is PVPP. In this case, we did some important additions, and this is just preliminary data, of inactivated yeasts to grant the good degree of protection, because the type of yeast can also be different, and that's a fact. And we compared the Australian pinking test methodology as well as our in-house methodology, which has been in use for over 2 years, which is the Australian methodology, but adapted based on the CA lab. And we saw a relevant reduction in preventative terms of the proneness of a wine to develop pinking. We needed to say that the Australian methodology had never been used to its full extent by us, because it is very sensitive to even minor amounts of iron in the wine, which can greatly affect the final result. Now, quickly, Dr. Zanella is going to explain this in more detail. This has to do with red wines. It is clear that each type of yeast has different characteristics, and these characteristics, if they are also kept into consideration when inactivating or when freeze drying, etc., end up having playing a different role vis-a-vis red wines, especially the smoothness, the reduction of astringency, as well as color stabilization and taste and aroma improvement and enhancement. One final application that I will describe that was interesting to me, because I work the world over, but I originally come from Conegliano, the area of sparkling wines. We used these yeasts in the spumante making process, and we came across two very interesting surprises. Of course, we used yeasts that already had an effect onto the foam of the wine, but what was particularly interesting was in working with this winery, which is part of the Prosecco designation zone. We did 3 repetitions in the same pressure tanks to test the results, and we saw that in a wine where the height of the foam could be big, because the company is a good one, we could still enhance it. We could go from 20 to 25 millimeters, I think, through a Monolux investigation. But the persistence of the foam was also interesting. At 50 seconds, you'd have a persistence of the foam that was better when comparing brut against brut, although not when comparing it against the extra dry. And that also enhances the roundness of the wine. We also analyzed the effect of adding 4 grams after secondary fermentation in all samples and with all repetitions. As explained in the previous speech, the fermentation that took place in the presence of inactivated yeasts came to an end, although under standard conditions, I mean same temperature and same everything else, and also same type of wine, that was more successful. I hope I gave you some indications that were perhaps more relevant from a technical standpoint for future implementations and applications. because I think that inactivated yeasts are the future, and perhaps the correct application based on the type of grapes and other aspects can be studied further to adapt these inactivated yeasts so that they give the best for each wine. Thank you very much. I'd like to thank Fabrizio Minuto and Gian Maria Zanelli also for the research work we